Hello everyone, Oleg is here. In today's video we're going to talk about data science productivity enhancement. Before we move on, a couple of disclaimers. We're not going to talk about some interesting projects I have implemented for the clients. As a hands-on data scientist, I will try to describe concepts, patterns, ideas, or even tools which help with my daily routine, for example, workflow enhancement. Secondly, I would like to notice that data scientists are also people and also developers, so we also use Copilot a lot. We use ChatGPT to write emails and so on and so forth. So I will try to minimize, not to zero, but minimize mentionings of the obvious cases like writing code with Copilot and so on. Thirdly, I'm going to highlight different providers with different policies, and very likely you are not allowed to use them directly with your client's data or with your company's data. So follow the ideas, follow the approaches, and having these you'll be able to find the appropriate tools, prompts which are allowed within your security contour. Finally, what I'm going to cover is relevant for the end of September 2025. Very likely most of these tools will not be relevant anymore in the next year. Instead of agenda, I'm going to follow this diagram. So this is called CrispDM, and it is a widely used framework that provides a structured iterative process for data science projects. So all the projects in the data science are structured around the data, of course, and everything starts from the business understanding. So you discuss with the business the requirements, what is going to be achieved, what are the KPIs, and so on. So after you understand the business, you switch to the data understanding. You collect, you study the data which you have on the project. You maybe request some additional data sets. You're also allowed to return back to the business understanding. So if after the data investigation you understand that the business, like requirements, for example, are going to change, you can go back and describe them once again. Afterwards, before you start some modeling, you conduct some data preparation, because not all models are able to deal with the raw data. You have to clean it, you have to prepare it, and so on. Then you go to the modeling. So this is the place where you apply some machine learning models, for example. Later you evaluate the solution, and finally you deploy it. Between some of the stages you're allowed to switch back and forth, but usually this is the flow which we data scientists follow for every data science project we are involved into. So the agenda will be the following. I will cover each of the rectangles on this diagram and will try to find some nice solutions on the web and which I have tried myself, which help and enhance productivity of a regular data scientist. So let's start from the business understanding. Data scientists work quite a lot with business side of problems. This is way more consultative or analytical rather than development-related kind of work. What I think many of us are missing is structured business problem solving. It is very helpful to have a chat in the format of classical consultant case study. For example, to dissect problem, to build hypothesis tree, root cause identification, prioritization, success criteria definition. AI makes sure within the dialogue that you apply best practices, for example, the MISI framework, which we are going to talk about in a bit, and help you to solve your problem according to one of the well-known frameworks. For example, one of such is the hypothesis tree. So you may have some problem, for example, low adoption of feature X, and you try to dissect it, keeping branches mutually exclusive, but collectively exhaustive. So you can see that the second level of the tree is created from two branches that are mutually exclusive. For example, here the low adoption of feature X may be caused by two options. Either customers do not know about the feature, or the customers do know about the feature but still do not use it. We can see that these are mutually exclusive, but at the same time, if we combine them together, they both kind of cause the low adoption of feature X. I've done this many times in the chat format and then visualized using some other tools, for example, some GPTs from OpenAI. AI makes sure you really apply the best practices like the MISI framework, so here it is. It makes sure that like the groups you substitute your problem into are mutually exclusive, so they do not intersect. but at the same time, all the groups you define are collectively exhaustive, so you do not miss anything from your problem. Here is some relatively simple example. Like, we have lots of complaints about our product and we want to reduce the number of such complaints by X% within Y month. What to do? Please create 2 levels of a hypothesis tree with maximum 3 items per level. So you see it creates 3 levels, like fewer incidents happen, fewer incidents escalate to complaints, and fewer false positive complaints. So we're just thinking about how to reduce the amount of complaints. Again, in the proper case study, if you have seen some examples on the web how this is done properly with consulting firms, you first have some conversation about like requirements, about some details of your case, and then you are able to create the hypothesis tree. So here I speed it up a bit, but nevertheless you can do the same procedure with, for example, ChatGPT, and it will able to ask the following questions so that you kind of as a business owner will be able to give the appropriate details about your solution, about your problems, and then ChatGPT or any other chat will be able to help you with these levels of the hypothesis tree. I have taken some existing GPT from OpenAI and just pasted the hypothesis tree which was generated in the previous tab, and you can see that it has visualized this to me pretty nicely. You can do this right here from scratch. I have just depicted this for the sake of visibility, and there are lots of pre-built solutions and you can build your own GPTs according to your preferences. There is another framework for prioritization you can ask AI to help you with. For example, having identified some potential solutions or features, you can ask AI to help you with finding the low-hanging fruit so that you categorize, for example, using impact effort matrix, and then select the one your team is going to implement finally. There are really hundreds of consulting frameworks, and again, as a reminder, we are not just technicians. Being data scientists, we are also some business problem solvers, and we have to think from the business perspective about the problems we have. So there are really tons of different and useful frameworks which usually GPTs are very well familiar with, and you can either ask to follow some framework or you can ask a GPT to suggest some framework to follow it and help you with your problem solving in the project. For example, once I was discussing a problem, again very anonymized and not something particular, but around the question of how to transfer the machine learning models from B2C to B2B products if there are some problems with the quality. So GPT was kind of brainstorming together with me what kind of facets you have to consider to address this properly. The next part of the business understanding is what I call archaeology or onboarding. During the investigation, you are very likely to look at several repositories and data sources. Being an experienced engineer, you are very likely already have several crucial questions. For example, like what is the infra, what is the model, what is the API? Some of the answers may be found in the docs, but you know that the status of the docs is usually questionable, and I always prefer to look at the code briefly in order to find the exact answers, like the status quo. The tool I use a lot is just Ask Your Repo. So surprisingly, this is still Copilot I didn't want to cover at the beginning, but these features like Ask Your Repo are usually available in Copilot-like tools, but not only. And I personally find the QA over repos working way better than actually code generation. I'm going to use the CajuMLflow tutorial from one of my previous videos, and I will assume that I do not remember anything, which is truth with it. This was more than half a year ago. So here is the structure of the repository, and let's assume that you are, for example, not familiar with the Casual repository structure. So you open the Copilot and you ask some very straightforward questions like, what is the purpose of this repository? Answer briefly. This is a sample Casual project that demonstrates how to integrate Casual with MLflow to build, train, log, and serve machine learning regression pipeline. So we move forward. What are the steps of the machine learning pipeline briefly? Like pre-processing, train validation, split, training, logging artifacts, and so on. And finally, for example, the things which may be of interest for you if you are just joining, like what is the model used, what is the target? So the answer is like the linear regression model from scikit-learn is used, and the target column is price. So we're going to predict the price of the space flight. There are lots of modern features. For example, you can ask GitHub Copilot to create some Copilot instructions based on what it finds on your repository. Like, it's kind of the other way to index, like to read the repository and study before you ask the questions. But at the end of the day, this is super helpful when you have some specific questions about your repository, like what's the API, what is some specific technical detail. But also this is very helpful when you want to get some very high-level overview of what is going on if there is, for example, no README in the repository. The other tool I would like to introduce with respect to the same kind of archaeology or onboarding is the Deep Wiki from Cognition, who are the authors of Devin, by the way. So this is the tool which helps you to build some documentation around your repository. For example, to create some API specs, explore code structure, find existing documentation, understand dependencies, help with the setup, reverse engineer the architecture, for example. So you can see that they have already pre-built lots of repositories from GitHub, which is already super useful if you're going to study, for example, LangChain. You can check what their agent decided to include into the documentation and study this in detail. So usually this is super helpful and saves lots of hours when you study the library for the first time. You can have a conversation as well. But let's look at the example from my side. So there is a RAG repository about my tutorial on agentic RAG. So this contains mainly the notebook, a very long notebook with different techniques observed. And let's look at what DeepWiki decided to include into the documentation. So there is a simple core architecture, which is not of much interest. This one may be quite interesting, like we talked about the LLM limitations, about the search techniques, about the traditional RAG, about the agentic RAG, multi-agent system. So this all was covered, and again, this is one of the pieces of documentation you can find on this page. So this is the way the notebook is structured about how we go through the material. We start from the foundations, then limitations, traditional RAG, search techniques, and then with some advanced stuff like agents and so on. There is some guide on how to set up your environment, like which Python you are going to use, how you install the dependencies. It also shows the RAG architecture overview, which I had in my setup. For example, the document processing starting from the source documents, which were web, PDF, text, some splitter I used for the documents, the embeddings I utilized, and so on. I have just decided to check if the embeddings were really from the OpenAI. They were from Sentence Transformer, so this is actually incorrect. So yeah, this is not correct actually regarding the embeddings, but I actually did use the FAIS vector database, then there was a retrieval pipeline, and then some generation pipeline, which is obvious, right? What I like, for example, is that I was talking about different search techniques which may be used in RAG. I was talking about lexical search, semantic search, and hybrid search. But interestingly, sometimes lexical search is called differently on the web. Sometimes I think it's called keyword search or maybe syntax or syntactical search. But I think I was using exactly the lexical search term, and this is preserved here, which is pretty nice. So again, maybe too much of the documentation for just one notebook and a simple repository setup. But at the end of the day, this is pretty helpful if you do not have any documentation and you just want to start from something. This is for free, so extremely helpful. And let's not forget that usually every company has some kind of agent or chat over documents inside the company, like internal knowledge base. And it is super helpful to study the KB using some agent so that it takes less time than if you scan through the Confluence pages, like infinite Confluence pages yourself. So as a practical advice from my experience, right after joining the project, immediately request Copilot, some yet another internal AI-powered knowledge base tool, and so on, so that you are able to study the code and the documentation faster. And I would say that this saved hours to me when I started using AI tools. Of course, always check what you found and what you get from these tools, but as of now, there are way less hallucinations and bad answers, so that you really save your time. As a reminder, we're still talking about business understanding. We've covered some consulting, some onboarding, but before diving into deep understanding and analysis of the data, we actually have to get it. I'm not going to dive too much into this because there are lots of great tools like Snowflake Copilot, Gemini in BigQuery or Looker, Databricks Assistant, and I'm going to show just one example of such. Beyond just basic SQL generation, AI really transforms how we interact with the enterprise data systems. They're really well optimized for data search, specifically on their platforms, for querying, for overall data discovery. I'm going to show just an example of how you basically can translate text to SQL, which is a very well studied area, and there are tons of solutions, both from big providers, from big players, and as well as some custom in-house solutions. For example, here on the Databricks free edition account, I have entered the SQL editor, and I'm going to show just a couple of queries with pure language. So show what tables are there in the samples catalog, and actually we have to enter this in the kind of AI input. Yeah, it decided to select one of the schemas, but nevertheless it was able to generate a valid SQL query. Well, I was expecting to see what kind of tables are available in all schemas, but nevertheless. Let's say we're going to take the AccuWeather, for example. So let's see. And yeah, we can see that the catalog samples schema AccuWeather has multiple tables, 12 tables, and we can select something from one of these. Like, let's say historical, daily, calendar metric. So let's say we're going to ask for the top 10 temperature days in one of the tables we have. So let's see if it works. No, it does not. There is no city name. I don't know why it generated it. So let's take everything from the table. Yeah, very likely this is what we need. So let's see if the temperature max actually exists. Yeah, so looks like these are pretty high temperatures in Baghdad. So this is approximately what I expected from such an agent. For this simple query, this was not very successful, but it was kind of helpful to generate some simple placeholder for the query. For more complicated, it may be more helpful because you have to combine multiple tables, join them, and so on. But on the other platforms, this was more helpful. For example, on the Snowflake I have tried, this was of better quality, but again, maybe because this is a free edition, that's why it's quite limited. But the message is a bit different. It's not about the SQL only, it's about overall data access with the AI. So you're able to find the schemas, for example, in your data catalog. You're able to query something with non-SQL. For example, with SQL, it's more or less well known, but if there are some dialects, for example, something unusual like other query language, for example, for graph databases, for some logs like in Kibana or in MongoDB, these look quite natural, but at the same time, these are not well known and not as widely learned as SQL. So that's why this is extremely helpful for the data systems which are not like standard SQL. So my thoughts on this: usually big players, for example, big clouds, have these tools well optimized and secure to deal with your data. So you can, instead of using ChatGPT, which may be not secure all the time, you can go here, for example, to Databricks and query your stuff using AI faster. Of course, these are far from ideal, but already can save some hours during your daily routine. Last but not least, before we dive into data understanding, How much time we lose while waiting for data collection, for data annotation, data access, data anonymization. In most cases, we know what the format will look like and what we're going to do with this data. And I personally think that the question of data synthesis is a very underestimated area for AI usage, for modern AI usage. I was dealing with synthetic data way before the modern AI, like generative AI, was used. You can check this old tutorial about how to anonymize the data so that you take some real data and make this anonymous, kind of synthetic. But now, using modern techniques, this becomes even more realistic. I'm going to cover some game-changing use cases from my perspective about the data synthesis and how it is used on the real projects. And then I'm going to show several nice frameworks which I found useful. So the main problem is, of course, the cold start problem elimination. So you can create and generate realistic datasets for new project prototypes so that you can start faster before you get the data. Secondly, you can create some edge cases for testing model robustness. So you know that you are going to train some models and your model has to be robust to some different use cases, for example, different demographic data, different timings, and so on. So this is very helpful to generate such pieces of data synthetically rather than to wait for these cases to appear in your data. The second game-changing use case for me is the privacy-first development. So you can even train without exposing sensitive customer data. So not to mention the analysis and some mocks, you can train the models using this data and they may be still of good quality if the data is generated well enough. And finally, about the use cases which I like and which I saw is about supporting the A/B testing. So when you want to make sure that you build the A/B testing platform or system in your company well, you can start some controlled data variations in your synthetic data, for example, generate data with some specific patterns in the texts, and then run an A/B test and see that this is well captured by the A/B test. I have touched briefly 3 data tools for data scientists. One of these is Gretel AI, so basically helps you to generate some synthetic data. It is API driven, so available for Python, supports tabular, I think image, text, and whatever. Another one is Mostly AI, which is again mostly tailored for the enterprise. Tonic AI, which has interesting solutions for the identification, for example, making some synthetic data based on your existing data, like anonymization, and again, maybe not surprising that all of them have AI domain. There are also solutions which are specific for health data. I heard that Tonic is able to generate some healthcare data, for example, if you work in this domain, so very helpful to check. So this was multiple times very helpful to me when I was waiting for the real data, while I really knew what I need to do so that I was able to scaffold the code, the process, and even the modeling, and then substitute the synthetic data with the original one so that everything remains the same. There are also some kind of bonus patterns which I have heard of, have never tried. So the first one is the scenario-based testing. So this is very similar to the edge cases, but basically you generate some specific data samples which are tailored to some business scenarios, for example, Black Friday traffic, seasonal patterns, market downturns, and so on. This is not only about the data volume you can just copy-paste from your existing data. But this is also about the patterns in the data. For example, user feedback is going to follow some trend in terms of words, opinions, and so on. And the final one, which I have also mentioned, but a very important part, is the data augmentation. So again, you have a very small piece of your real data and you want to train something, but you definitely lack the scale of the data. So some solutions, for example, like Tonic, is able to expand your data set, preserving some properties. And cool story. So once I was on an interview and I was asked to perform some analysis based on the data from some database. Let's say analyze some user behavior or so. I told the interviewer that, of course, for the sake of interview, I will just hard code some data in the CSV, like a dump from the database. So they refused. I asked if I can use AI to help me to install the setup and so on. So it was allowed. I asked AI to help me to install the database I have never worked with. Then I took the schema from the interview and asked the AI to create a data sample and then fed this data sample to the database. So it took about 5 minutes of the live interview so that I set up the database and create some synthetic data. And I also showed how I'm dealing with the chat assistant and generate some synthetic data and then analyze it using both AI knowledge and my knowledge. And the interview was quite successful because I was able to solve the task in the dedicated time, especially for the database I have never worked with. After or even during you get some understanding about the business requirements and how the business operates, it's time to look very deeply at the data. I will first show an interesting benchmark which I check from time to time, and then I'll give some thoughts on the usage of the tools. DABStep is a tiny benchmark of 450 analytical questions about various documents. Some questions are simple and require just one document to be answered. Some hard questions require multiple documents to be taken into account for the answer. I think this database was created together by Adyen and Hugging Face based on some real financial data. Of course, this is not very diverse, it's just 400 something questions, but the idea is that these are real questions very similar to what we data scientists are trying to answer during our routine. For example, having some data set, like which card scheme had the highest average fraud rate in 2023. And then the agent is able to take the data, perform some analysis, and give the answer. There is a leaderboard which I mentioned for easy and hard questions. This is pretty frequently updated from different providers from different teams. Such agents are developed relatively actively on the web, and I have tried a couple of them. I have tried the Colab, which when it was released was positioned the 4th, I think, and the Jupyter agent from the Hugging Face, so I will show you some brief demo of both. But the main way I was using both was just giving them some dataset and the task to perform. So let's start from Colab. I have already uploaded the weather training data from the Kaggle. It is in the CSV zip, and now we're going to give the task to the Colab agent and see what it is able to do with our dataset. So consider you are predicting weather for a B2C company which sells these forecasts to their clients or customers. Please perform some brief EDA, data processing if needed, modeling, evaluation, interpretability, maybe some explainability. Analyze the data, answer the main question. If it's going to be raining tomorrow, please don't forget the business part of the question. Also consider some business metrics so that this is feasible for the business to utilize such tools. So we copy this so that we're able to try the same prompt with a Jupyter agent, but I have tried both multiple times with the same task with a very similar prompt, and I will share my experience and overall thoughts after our experiment. So let's go. It should provide some plan and then act according to this plan. I have tried to give it a go after it suggests the whole plan and tries to perform it step by step together autonomously. It didn't work very well, so that's why I prefer to perform the analysis step by step. So here you can see it suggested like load and inspect the data, perform EDA, missing values, process data, train a classification model, which makes sense, evaluate the model, interpret business question, business metrics, findings, and final task. You can go with just one click and it will do everything together. You can run step by step. For me, this works usually better. So it is going to read the data. Let's see if it will be able to do so. It is. So interestingly, the dataset is in the CSV zip, but Pandas is able to understand and unpack the data if it sees zip in its path. If you, for example, say that the file doesn't contain zip, but actually it's an archive, it will not be able to open, it will fail. So that's why you have to explicitly unarchive first and then read the CSV. But we can see our data. We have 23 columns, some columns contain nones, and then it starts some deep dive into the data. Let's see. So there is some reasoning for each step, and each step is executed separately, so it kind of makes analysis and then suggests the second step of the analysis and so on and so forth. I do not like that it doesn't make any conclusions after each cell, which I usually expect for the data scientists, but nevertheless, let's see what the analysis it suggests. So the distributions of the main features, these make sense. The amount of nulls in terms of percentage also makes sense. Sunshine is almost half the values are empty. Then we'll look at the categorical columns. Let's give it a try. We'll look at the amount of the unique values, for example, the wind direction, mostly north, east, and so on. We have different values for wind for different parts of the day, like for example in the morning, in the afternoon. We also look at the values for the rain today, and interestingly the values for rain today are not binary. These are no and yes, which are string values. So let's see if the Colab agent will be able to process it properly. So visualization of the numerical and categorical features, let's give it a try. Interestingly, it selected not all features, there are way more, for example, locations, different cities in Australia. And let's see if this will be enough to predict well. So the distributions are interesting, I like them, they're pretty neat and useful. Like for example, the minimum temperature, the amount of each bucket for the whole data set. Maybe it would be better to split the data first than to perform the analysis on the whole data set, because you kind of leak and make conclusions on your decisions and steps, further steps based on the whole data set, while actually you are not able to look at some pieces of the data in advance. This one is not very fruitful, but actually the distributions are quite interesting. So let's see, there are some mistakes or warnings which will be very likely ignored. Yeah, they are. But the distributions are pretty interesting. This one is not very neat, but at the same time the distributions are what they should be, like distributions of features, distributions of the raining for today and tomorrow. We can see that this is more or less the same, which makes sense. And then it is going to look at the correlations. So we expect a lot of correlation with the target feature, which is rain tomorrow. And again, as a reminder, this is built on the whole dataset, which is not perfectly correct. So we see that, for example, humidity at 3 p.m. is quite useful. Sunshine is also negatively correlated with the rain tomorrow, for example. If today is lots of sunny hours, tomorrow likely will be no rain. The box plots are also fine. Maybe there is no need to build box plots before, for example, taking logarithm of your data, because these are not useful at all. But at the end of the day, there is some analysis. So let's see if there are any conclusions based on that. Not much. So we see that the agent is going to handle missing values. It doesn't say much about what it found previously. So address any missing data identified during EDA using appropriate techniques like imputation or removal. And this was achieved right at the very beginning, I think. So when we were looking at the missing values. So this is based on that. So not on the distributions, not too much. And I think it is going to impute, not impute, it is going to fill the missing values with median and mode. Maybe the default options, something more interesting may be suggested, but this is also fine. Several columns are dropped because they are poorly filled. They contain more than 40% of missing values. And now we're going to process the data. So let's see how it will go. Prepare the data for modeling by handling categorical variables, scaling numerical features, and splitting the data into training and testing. Let's see if it will be able to do this properly. So the rain today is transformed via label encoding, which is fine because there are only two original unique values, no and yes. They are going to be converted into 0 and 1. Probably there is no need to train the label encoder, And of course, it is always better to split first and then check if you are having the same amount of unique values. But for this label, this is pretty straightforward because it has only 2 unique values and you cannot imagine something between these. So one-hot encoding is very simple for all the object, like categorical values. Then we select the target and extract it from the dataset. We select the numerical columns and make the fit transform, which is a bad practice because you have to split the data first and then apply the fit transform. So this is actually a huge mistake. And also for our dataset, there are lots of time-related components. For example, we have multiple locations and each location has some connection to the timeline. So we have some historical values for the weather and we are going to predict for the future. And splitting by default with train test split is a mistake because by default it has shuffle true. So, surprisingly the notebook crashed, but it was able to proceed, which is pretty good. So by default, train test split uses shuffle true, and if the data was sorted, this is missed. Even if it was not sorted, you have to figure it out, what is the order of the data, and then only then perform the data split. So we execute this cell ourselves. I have never seen this crashing like that. So probably have to execute this once again from above. So this cell was exploded in the memory, very likely because it tries to make one-hot encoding from the row ID, and row ID contains lots of unique values. So yeah, it tries to make 100,000 columns, and that's why the memory explodes. So let's probably ask if it is able to rewrite this piece. So I have mentioned this to the model, like, are you able to rewrite the data processing step and return back to the plan? You were trying to encode categorical variables, including row ID, which contains 100k unique values, which is a mistake, actually, and it is able to return back. Let's see if we'll be able to proceed with the plan. Yes, absolutely right. Row ID should not be included into one-hot encoding, so we're kind of collaboratively trying to fix this, and yeah, it excludes the row ID and tries to move forward. Let's see if it will be able to. Okay, at least now we're not failing with the memory. A good sign. And yeah, it is going back to the plan, building and training a classification model. Again, this original plan is not highlighted anymore, but I hope it will try. So there was some failure. Let's give a brief look at what we have in the xtrain and xtest. So we still have the row ID in our data, which is probably useless for our use case. Again, this would be probably useful for the data sorting if the data is sorted by time, but the agent hasn't analyzed this and we do not know much about the row ID. So it removes the row ID, which makes sense, and tries to proceed. So let's trust it. Yeah, so weird. It is writing from the place where my cursor was. So that's why the notebook is not linear anymore. So it is evaluating the model because, yeah, this cell was already executed. So we see some accuracy, precision recall F1 score. Let me put my cursor here because it will proceed moving upwards. Now it is going to interpret and explain the model, and looks like this is it. Yeah, so probably I interrupted this accidentally. I will give it one more try. Let's see if it will be able to do this smoother, but you already see that this is not ideal. So I have created a new notebook and I have copy-pasted the same prompt we used previously, the same dataset. Let's give it a try one more time. I will be a bit less detailed with the explanations of what is going on. I have tried this so many times and I'm already able and ready to share some thoughts, but I want you to look at the real-time way it is going to analyze and how interactive it is, so that you're able to estimate if it's helpful for your kind of problems or not. So the data is read successfully. So missing values, plots, I expect everything to be more or less the same. So interesting distributions, box plots, distribution of location, sorted by the amount of appearances in the dataset, distribution of the wind direction, target label, and so on. Interesting distribution about the wind direction versus raining. And we can see that some of the wind directions are more related to the rain, like western, and for example, the least amount of rain is for this kind of wind direction, which may be very useful for the modeling. So the numerical values are also filled with mean, previously median, now with mode, the categorical ones. Again, I would expect a bit more analysis on how to impute the values rather than just selecting something as a default. So we're going to one hot location, which is a questionable step because we have so many locations, but at the same time, location should be one of the most important features because, again, depending on the location, the prediction may be completely different. So makes sense. We use column transformer from scikit-learn. We could probably use the get dummy values from the previous example. So we have created the data sets, which makes sense, about 100 variables for 80k rows. This is trainable for some simple models. I don't know what is going to do with the date. I think we do not have date column. Yeah, we do not. I hope this time the Colab agent will be able to solve this problem. Okay, it's going to do from the first attempt. There is no date column, please understand that. As a side note, I would say that for me, the success criteria or end-to-end run wasn't 80% of my tests. So these two are consecutive failures. Keep in mind that this also happens. I didn't want to cherry pick. I just want to show how this works in the real scenario. So it tries to debug the problem with the dates. We didn't have any dates in our dataset. We can check with the Kaggle if this is really given. It is not. And date is not here, so it is checking this and then is probably going to repeat everything. So it reads the data once again, looks at the columns, and then returns back to xtray and xtest. Actually, it was trying to sort by the location and date, which makes sense. This is how I would probably split the data so that we're able to predict for each location for the dates in the future. But the data is not here, so I would expect a bit more deep analysis about how the data is sorted originally, rather than just splitting this randomly. But let's see how it will process. Yeah, it still fails because the input contains nones. So it is going to process the columns once again. I'm not already checking any detailed mistakes because there are already quite a lot. It was able to train the logistic regression successfully, which is great. By the way, it's interesting that it added a step into the plan for the feature engineering reach Y. I have never seen this previously, so usually it fails and tries to perform the same step more and more, but now it adjusted the plan. I think it was not here originally. So we have some evaluation, we have some accuracy measured pretty fine, precision recall. I hope it will elaborate why it uses such metrics, but this makes sense. So now it is going to analyze the model to understand which features are most important for predicting rain and explain the model's predictions. So it is going to take the coefficients from the logistic regression. Yes, it takes the coefficients and then sorts by the absolute values, which is correct because they may be positive, negative. And we look at the maximum ones. So the pressures, we looked at the coefficients and the humidity are the most important ones. The locations are also very important features. Surprisingly, it took rows as columns, which is not correct. But for some reason there were still 100 columns, so it looks like not all row IDs are taken as categories. I don't know how it took this, honestly speaking, but this is weird and not looking fine. This is a very strange move, so it takes the whole dataset and says like the last row is like the last date we have available and we are going to predict one time more, while actually it was able to see and realize that the data actually contains lots of cities. So even if we have the last row of our dataset with the last date, we have to perform this for every location, while we're doing this only once. And it does the prediction like there is no rain tomorrow. So this may look convincing, while actually there are so many mistakes. It makes some interesting conclusion about false positives, false negatives. This is the very thing I was expecting, because it's so useful for the business to understand these kind of numbers. For example, false positives predicting rain when it doesn't. And here is the impact. Customers might cancel outdoor plans unnecessarily, leading to frustration and decreasing trust in the service, which is true. Business risk, potential loss of customer satisfaction and churn, also true. And false negatives, which are predicting no rain when it does. Customers might be unprepared for rain, example, not carrying an umbrella, leading to inconvenience and dissatisfaction. So significant damage to credibility and reputation, especially if it leads to negative consequences for users. And I really like that the Colab agent makes some thoughts on which kind of metric is more important for us. For a B2C weather forecasting company, precision, minimizing false positives, is often more critical than recall, maximizing true positives. Reasoning. False alarms predicting rain when it won't can quickly erode user trust and lead to users ignoring future forecasts. While missing a rainy day is also negative, frequent false alarms can be more detrimental to daily user engagement and satisfaction. A higher precision means that when we say it will rain, it's very likely to rain, which builds convenience with the user. A low recall means we'll miss some rainy days, which is inconvenient but less damaging to credibility than crying wolf too often. Therefore, in this B2C context, prioritizing precision over recall appears to be a sound business strategy, assuming the recall is not drastically low. This makes a lot of sense. Of course, this is better to be consolidated together with the business stakeholders, but the logic makes really a lot of sense to me. So there is some summary at the end of the notebook. This is what I really like, and I like when data scientists make these conclusions at the end of their analysis. So it states that there is some missing data. It also states that there is some target variable imbalance. I do not remember any attempts to deal with that. So there were no attempts to undersample, oversample, maybe use some weighted modeling. So it just states that the vast majority of the days are not raining. Feature engineering is limited. This is true. There were no time-related features. Again, maybe with some analysis on the web and in the data, these would probably show that there is some time component in the data, but the model didn't study that. The quality of the model is stated, the metrics are stated, some key features like humidity, rain today, pressure in the morning, and wind speed are mentioned, and insights and some future steps are suggested. So before we switch to the Jupyter agent, I would say some rough analysis from several attempts I have tried with this data. I have launched this exact dataset multiple times. I have tried in the past some other datasets I had. So the rule of thumb, the simpler the question, the simpler the dataset, the better is the quality. So this is basically what the benchmark says, the one we have covered. So I really like the proactivity, and it really speeds up the process when reading the data in custom format. For example, if you do not have any idea of how to read the CSV zip, this may help sometimes. But it's clear that it misses tons of nuances and sometimes cuts corners too harshly. However, some ideas and visualizations may be useful when you feel that you are stuck and you don't have some inspiration, and you don't know, for example, which aspect of your data to analyze. So this proactivity really helps. I would personally not leave this agent with my, for example, prod data, of course, not to mention the security issues, which you have to consider when using some open solutions like Colab, but keep in mind that this will be very unsecure and unsafe. It will do whatever it understands is correct while not keeping in mind some business information from your domain, for example. I generally agree with the conclusions from this page, so give it a look if you have a bit of time and if you're interested, but generally the conclusions and the analysis, the study, are very similar to what I have in my mind. But let's do the same exercise with the Jupyter agent. So this is running based on the Qwen3 coder, the large model, and this is built by the Hugging Face. So basically this is an agent which is running over this model and just creates notebook cells one by one, similarly to what Colab agent was doing. So I have uploaded the same data and I'm going to paste the same prompt. I think this is capped by 5 minutes, so it will not be able to run for more than 5 minutes, but we'll be able to look at some main points for this agent. So it is generating the cells in the same format, so it has some kind of support for the next cell. So it generates the cell code, gets the output. It was also able to read the data, but then it doesn't give any conclusions, which I miss a lot, and continues with the next cell. So here you can see it reads the data in a bit different format. So it at first extracts the zip file and then reads just the CSV. So it looks at the amount of missing values very similarly. Then looks at the target column, makes sense. Calculates the describe, which is the basic step. Then tries to remove the row ID column and does this unsuccessfully. Makes some mistakes, looks like there are some nones, and it tries to proactively fix the issue with the data type conversion. So it tries to convert the rain tomorrow from no and yes, while we know that for rain tomorrow this is already done, but for the rain today we have to do this. So let's see if it will be able to find this itself. So fails once again, fails another time, looks at the unique values, reads the data once again, and decides to look at the values for the rain tomorrow, realizes that these are already numeric, which we already know. So they proceed with the analysis, looks at the feature correlations with the rain tomorrow, so it actually tries to see which features may be useful for the prediction. So humidity, as we already know, cloudness may be useful. It takes the categorical values, location, wind direction. I like this. Honestly, it would be better to encode them in a bit more logical way. For example, wind may be encoded by the compass direction instead of just making unique values randomly. So it does label encoding for the categorical features. For the numerical ones, it uses median, as we already know. It uses quite a lot of features in comparison to the Colab. And we see that using the imputation or filling the non-values, it was able to preserve quite a lot of data, almost the whole data set. Lots of warnings. Let's see if it will make some conclusions based on that. Looks like not. We have some data and it is going to deal with that. So yes, finally it removes the row ID, which makes sense from our previous analysis. Splits the data. Interesting point is the stratification. So the stratification makes sure that the distribution of the target value is the same between the train and test, which makes sense, but at the same time, the same problem. So we first do encoding on the whole data set and then split the data. So this is a junior level question for the interview. We know that this is not correct. So then it trains a couple of models, which makes sense, and compares their performance. So we have the logistic regression, we have the random forest. They have different metrics. Let's see if it is going to make some conclusions based on that. Not much, but it calculates the feature importance for the random forest, humidity, pressure, as we already know, are quite useful. Compares the confusion matrices, calculates the feature importances for the random forest. For some reason it doesn't plot for the logistic regression. Maybe it says that the random forest is better. calculates the business metrics. This is of interest for us. Oh, this is so cool. Let's give it a look. So true positive, true negative, this is explained well. There is an interesting attempt to give some values for the false predictions. For example, we say that the cost of false alarm is 10 units, for example, $10. The cost of missed rain, higher as it affects customer trust, is 100, which totally makes sense. This is something I would like to prototype with. So for example, during this investigation, we do not have any real business values, real business metrics, KPIs, but we would like to make some business connection to our actual technical task, like for example, how technical tasks are transformed into some money. From the true positive, we get some positive value, for example, some subscription we can suggest to our users. And let's see how these two models deal with the data. So true positives, false positive, and so on. So the total cost is this amount of money, total revenue is this, net profit is negative. So let's see how it calculates cost. So cost is basically from the negative predictions. So we even do not count any infrastructure, any development. So this is purely from the user kind of trust. So this is negative. This one also has negative, maybe a bit better. And finally, it says that random forest generates more profit. Actually, net profit is negative, but it's more or less negative. Again, I would probably argue about some nuances of this analysis, but this makes sense. So the model tries to make sure we have some business logic here. So let's examine some relationship between key features and rain prediction to better understand the business implications. Average humidity when it rains tomorrow, average humidity when it doesn't rain tomorrow makes sense. The more humid it is, the more likely it will be raining. For the sunshine, it should be the opposite. Like the more sunshine you have, the less likely tomorrow it will be raining. Maybe it will be also interesting to calculate some intervals, but this is also interesting for the analysis and makes sense from the human perspective. So it also compares the ROC curves, which is fine, maybe not very clear for the business, but also useful for the technical judgment. An interesting move, it tries to optimize the model threshold based on business costs and create a final recommendation. So what we can see from this kind of optimization is that we set the threshold for random forest to 0.1. So this means that every time the probability is higher than 0.1, we say it is going to be raining. For example, if the model says that the probability of raining tomorrow is 20%, we say it will be raining when we binarize the prediction. I would be careful with the probabilities because it's better to calibrate for some models, but nevertheless, this is quite a strange move, but interesting. And we say if we say more frequently that it is going to be raining, we have better profit than with the default threshold of 0.5. When above 0.5 we say it is raining, when below we say not raining. So this is purely because of this value for the false negatives. So this is the case when we say no rain, but actually the rain occurred. And this is customer dissatisfaction because we kind of made them become wet from the rain. So we're kind of quite blind for the false alarms, but this is kind of okay from the perspective of the agent. Again, this may be not ideal, but makes sense from some perspective. So business recommendations based on our analysis. This is similar to the end of the previous Colab version. So the recommended model, random forest, optimal threshold 0.10, accuracy, ROC, AUC, business impact we have just studied, key factors, we have also investigated humidity, pressure, rainfall. Business recommendations are more or less the same. So some additional insights, true positives, false positives, so confusion matrix, detailed business analysis, for example, base subscription fee, 5 months per customer, premium alert service, $2 for accurate alert. Very curious how it is going to charge users for that. Customer churn, cost per missed rain, false alarm cost. Yeah, the numbers are quite questionable. For example, false alarm costs 1 month for user. I think we calculated something with different numbers, but these also may be interesting to investigate. Here it also doesn't suggest or assume any amount of users which are tested within the platform, because this would make some difference, I would assume. And now it conducts some analysis between different locations, which is interesting. So top 10 locations in terms of records. So there are some high rain locations, low rain locations. Very interesting decision to emphasize premium alert service for some rainy locations, and the customers will value accurate rain predictions because they live in such conditions and they suffered from this. But at the same time, they may be even more prepared to unexpected rains. For low rain locations, focus on base subscription service so that people are charged while you're not bothering too much, and minimize false alarms. So it's a very interesting idea to maybe train different models or maybe optimize one model for the location more actively. And yeah, consider geographic segmentation for marketing. And again, when it rains tomorrow, average humidity is this one. When it doesn't rain, different. So these are some kind of probes and interesting plots which I would probably not come up with while studying my data. And here are some ideas for the pricing strategy, which we have already seen. Some more bar plots, and I think here the time was up, but I think the conclusion from the model is more or less clear. So it suggested the business treatment for the numbers, for the current quality of our models, how it will perform in terms of money. So pretty makes sense. From my very rough experience, Jupyter agent fails less frequently. For example, I rely on it way more when I want to analyze some data while not being concentrated on that. So I just throw the data and ask the question and then return back for the answer. So if I have something within 5 minutes, this is usually the case, what I can dedicate to the Jupyter agent. So some conclusions with the data science agents. So again, I was mostly thinking in terms of data understanding, but of course you see that it also covers all the other steps like business understanding, data preparation, modeling, and so on. So mostly I would probably evaluate this from these two perspectives, data understanding and data preparation. And thoughts are the following. So these are pretty useful for the boilerplate. Usually they're able to help, for example, with reading some complicated data formats like Kafka. This is very similar to actually what any Copilot will suggest you. It will just generate some boilerplate for reading the data. In terms of processing the data, I would be quite careful because when it comes up with some features, for example, during the feature engineering, and when it prepares the data split, it is usually too harsh and makes lots of mistakes in terms of time-related split and in terms of shuffling, in terms of feature preparation before and after the split. So I would say that very likely the agent will make a mistake rather than be careful with that. So I would say that I use AI, in general, generative AI, a lot for plotting. So for me, the plotting became even more descriptive and declarative. For example, plots like these, you can see that there is a lot of boilerplate and the code is very similar, while the matplotlib is quite complicated in the amount of things you have to keep in mind in terms of colors, in terms of ticks, numbers, and for example, titles, legends, and so on. So usually it's better to ask declaratively to the AI, like, generate to me these kinds of plots with these kinds of features, and it will be enough for it to do this for you and save you some time in terms of productivity. Of course, you still have to check all these things because you can see from my demos and also from my personal experience, these make lots of mistakes, but for visualizations, this is better, and AI really speeds up the process. So very frequently, surprisingly, AI suggests very interesting visualization ideas, for example, some plots like these or even some even less expected. And I really appreciate that in terms of maybe looking at your data from different angles. And I would roughly say that we can treat AI coding assistants, I mean classical software engineering coding assistants, on more or less middle level. You can get a well-described task and solve it with an AI agent, so it will be able to solve it themselves, while still this task will require some review from your side, from a human developer. For the data science tasks, I would say it's more junior, and I would say I have to even guide an assistant on how to better do some steps. Not only say I'm going to perform some data processing and data split, but also say like, hey, please take into account the time component of the data, please generate this, and this feature. Use like, for example, logarithm of these features may be removed. So usually when it decides on itself, this is mistaken. But I really enjoy where it goes, so I totally recommend looking at the DABStep benchmark and some others for the data science specific tasks, because the way of work is very similar to what we're actually doing. We have a brief description of the task from the business, we have some piece of data, maybe several data sets, and our goal is to transform the data somehow that the answers will be found. So this is trying to mimic what we're doing actually. After you get and understand your data, and before using some models, very frequently you have to apply some data processing. So these techniques are usually standardized and have to be solid and simple to make sure there are no leaks and so on, as we have just discussed. So these include, for example, data split between train and evaluation, missing values cleaning, features calculation. Here copilots or agents we've just discussed are helpful only with simple boilerplate like simple calculations, aggregation and so on. Maybe you can consult about some a bit more advanced stuff like how to encode periodic ordinal categorical features like week, month, but these are usually more consultative when you go directly to ChatGPT and ask these questions and brainstorm together and only then apply in your code under your control. So when the agent decides to do this themselves, this is usually prone to errors. So it's very important to avoid leaks and in complex cases and in case of lots of, for example, nuanced features, this may be really harmful if you outsource this to AI. So I personally use this only in case of super simple features and super straightforward validation strategy, but generally the data understanding and data preparation are subject of just consultation with AI. So you brainstorm together, you consider different use cases, you for example ask per feature, per category features, like what may be a good option to process this, or maybe for your use case, what would be the best data strategy. So use this for creativity, for exploration, but do not rely on AI fully. So you definitely have to be very careful with the data split with the features. Usually they are standardized. You rarely come up with something really unusual, something surprising. And this part of the data flow of the machine learning workflow is usually more or less standardized. So mostly the boilerplate is something AI can automate and help with. Everything else, better to rely on yourself. There are some examples of the data preparation I heard of. I have not tried exactly these, but for example, for handling missing values, for data processing, for feature selection. Again, this all is possible, but for example, for feature selection, there are existing good machine learning options without any generative AI. For the data processing, there are also standardized way, for example, to take a log of your features, square root of your feature, and so on. For the categorical features, there is also a list of options to process them. So very unlikely AI will come up with something unusual, but if you are not aware about such, just consult. So in terms of modeling actually, machine learning is unfortunately not a dominant part of data science. So on the image you can see that this is kind of 1/6 of our occupation, but actually from experience I would say that this is even less. So usually the most time is spent on the first part, and modeling is just applying something straightforward. Maybe trying to squeeze some performance, but at the end of the day, modeling is just a small part of the data science routine. But depending on the role in the project, you sometimes have to concentrate more on reading papers and finding a good solution to your unusual problem. Sometimes you instead pick a relatively obvious machine learning algorithm, but spend more time on the question of how to scale it effectively. I would like to start talking about the enhancement of data science workflow and productivity from this tool, which I use still a lot. This is called Connected Papers. So this is the way to look how the paper you're studying currently is related to some others who quote it, or maybe which papers your paper quotes. And you can see the time range for different research and how they're related to each other. So this is pretty useful to study, for example, the related work. And this was useful even before the wide adoption of modern generative AI. So actually it doesn't use any, to the best of my knowledge, so that's why I'm not going to dive into this much. But this is something you generally start with when you search for a good solution for your exact problem. Another useful tool is when you have already found some papers of interest and you want to check for the passages and study in details. You use, for example, Explain paper and many other options available on the web. So basically you upload the paper and then you are able to ask some questions, and these will be answered by an AI tool precisely taking your paper into account. So there are lots of them. Some of them are just a basic QA. Some of them are more tailored to the scientific background, so they help you to understand, for example, the abstract, the experiments, and so on, and find some connections to the other papers at the same time with explanation of the quotations, for example. But all of them are more or less similar to the Notebook LM. So Notebook LM is a very well-known source from Google. Via Gemini, you are able to upload multiple documents, create some RAG system based on them, and configure your QA over them. So usually I use this to find some information in the documents I have. Some of them are more about the product or the business. Some of them are, for example, papers. You can combine them together to synthesize some knowledge based on business and technical achievements together. I would say that this is a bit more QA-like, so it's still creating some RAG, which is utilized for answering the questions. And for example, for synthesizing something based on these documents, the Notebook LM is not very helpful, so it's better to extract the information you need and then go to the classical Gemini or GPT and generate something you actually need. But this is super helpful, for example, to dissect multiple papers you have in your mind. So all these tools are really necessary at the very beginning of your modeling or investigative approach with the machine learning algorithms, when you try to understand which algorithm will be the best, what are the nuances, so that you upload multiple papers and check what may be the ablations and so on. Also at the stage of modeling, I usually discuss some architecture decisions with AI. So as a data scientist, you are not always a DevOps or cloud architecture expert, and I personally use LLMs a lot to brainstorm and validate some MLOps design. I will give you a couple of examples of the queries I have tried with the GPT and I usually do on the daily basis. For example, I need to deploy a real-time prediction service on AWS SageMaker. The model gets about 100 requests per second. Should I use synchronous or asynchronous endpoint? This is a classical question. What are the trade-offs in terms of cost, latency, and scalability? Answer very briefly in the format of if X, then Y. So this is what I did specifically for this demo, but usually you have some proper conversation with AI about your project requirements, SLAs, some expectations, some limitations, what you already have, of course, if it's not private information. And then you ask some specific architectural decision question. For example, shall I go with this service or that one? Shall I combine them in this way or the other way? And you get something like that. If you need sub-second latency with this RPS, use synchronous real-time. For example, if the requests are bursty and tolerate a couple of seconds, then you could probably go with the synchronous one, so and so on. So this will dissect you some thoughts from the web. You can even tailor this to some documents. For example, ask to consult with the AWS documentation. It will give you some reasonable answer tailored to the best practices from the documentation. Or another example, I'm not going to show some examples of how the GPT reads diagrams, the visual diagrams. It does it pretty well. But for example, I'm asking to explain the flow, how SageMaker endpoint works using ASCII. So there is some client request. It is going to the SageMaker endpoint. Then the SageMaker endpoint is deployed together with the endpoint configuration. Then it is going to the container, to the model container, which contains the Docker image, which uses some artifacts usually stored in S3. And then there is some input FN and output FN functions inside the Docker image. And finally, it retrieves the HTTPS response. So you can see this is nuanced and not ideal, but this already gives you some sense about how it actually works. And this is super helpful to understand on the very high level how this works. And you can give it some architecture if it's not private, and it will try to dissect and help you understand this. These aren't set in stone, but personally for me this helps a lot to become a stronger conversation partner when speaking to DevOps, for example, and really be able to deploy something yourself. For the actual coding section of the modeling part, I would say everything is the same as for the other developers. AI helps to write utils, infrastructure as code, CI/CD scripts, so very similarly to all the other software engineers, we can open Copilot or any other tool in our IDE and ask to help with some boilerplate or with some code. So again, here it is a bit more mature because software engineering is kind of the main direction of improvement for such models, so that's why this is as well helpful for us as for the software engineers. So some thoughts in terms of modeling. I would say that AI is democratizing data science, so it lowers the barriers to entry. Specialists in fields like social sciences or biology can now analyze their own data and train models without needing to become expert programmers or DevOps. I can't say that vibe researchers are our future, but this really allows domain experts to focus 100% on their research problem, with AI handling the implementation boilerplate like I was showing in the examples. Evaluation is very similar actually to the data collection. So we have already covered that generating test cases, and especially corner cases, is very important and very helpful when you use some generative AI. For example, let's say that you are predicting some churn, and you can ask some AI, for example, what are some tricky questions, what are some tricky edge cases or silent failures I should test for? For example, what about new customers with very little history, or customers who use the service in unusual ways? Another very important technique, very old but still gold, is LLM as a judge. A relatively old approach, but it becomes more and more reliable, so it's very convenient to use. Why it becomes more reliable? Because hallucination becomes less and less of a problem for the modern models, and structured output helps here a lot. And I always say that generating is harder than checking if some conditions are met. So you can generate plenty of text and then check this step by step, or maybe condition by condition, feature by feature. You can check if the text meets one condition, if the text meets another criteria, and so on. So you can spawn multiple LLM as a judge agents to check your data and then collectively create a report, or you can do this step by step sequentially. But it is usually helpful to keep in mind that instead of hiring too many people, you can hire a bit of people and then automate some part of the evaluation using some LLMs, which will also boost your productivity. Another thing which helps with the time saving is the framework which I like a lot. It is called RAGAS. So I use this for checking the performance of the RAG systems I'm involved into. So RAGAS combines the best from the both worlds, deterministic and non-deterministic. So there are some metrics which require language models, even not always large language models. And some metrics, for example, text similarity, do not require anything except embedding generating models. So this is usually very helpful to dissect your RAG pipeline into stages like first retrieval, then generation, and you see where your metrics are not performing so good so that you can concentrate on the right part. So for example, you make sure you are able to retrieve the right documents before passing to the LLM, or you see that, for example, you have the right documents all the time retrieved from your system, but then LLM hallucinates or does something not well. So there are lots of similar frameworks. For example, RAGAS, there are some from LangChain, which help you to compare prompts, compare approaches on the wide variety of questions. And of course, they still require some manual annotation sometimes. But when you use frameworks, this really saves lots of time to ship to production faster. Another paradigm which is used a lot nowadays is, as you may have seen from my words probably, is human in the loop. So the idea is the following, that you have to perform some kind of analysis or some action based on the data, and you already have some model. But the model may be sometimes confident, sometimes it may be unsure or wrong. And what you do in case when the model is confident, you say that I have the accurate prediction or maybe some accurate analysis. And in the cases when the model is unsure, some human is involved into the loop, and then the human produces the accurate prediction. A human in the loop is not just saying that an agent or maybe some model works together with a human. A human in the loop nowadays becomes some way of creating systems when human is expected to be in the loop and expected to work together with AI in the specific format. So for example, human has some specific UI or some specific application which they use during the work time, and they get some requests in case, for example, model is unsure. So this is not only about checking your model predictions afterwards in the CSV format. This is something specific on the real system level. This system may be dynamic when multiple people are involved. This system may be self-updating. For example, when human reviews and corrects multiple predictions, the system is updated, or this is somehow taken into account. This is used a lot, for example, in finance, for example, for the fraud analysis. So AI is trying to check the, for example, transactions, and then in case of complicated use cases, human is involved because human is very pricey, but at the same time, model may be scaled well. So this really helps to balance scalability of AI with reliability of human judgments, and not only for the production systems, for the inference. There are lots of data sets which are annotated like that, in the way when some models are trying to annotate the data on the go, but if there is a difficult use case, human is involved, and then the model repeats and becomes more and more clear with what is expected in terms of data annotation. And finally, talking about the evaluation, I would say that some kind of automated error analysis also exists. So there are lots of ways to analyze your data even without any LLMs. You can cluster your mistakes, you can calculate some statistics on the data set with your mistakes on some production use case. But in case you analyze text, it's quite difficult to calculate statistics. There are some, but these are not very useful usually. So you can use LLM to cluster and categorize mispredictions automatically. For example, analyzing misclassified samples and grouping them by some semantic similarity in failure modes. And for example, this helps to answer questions like, why is the model failing, rather than how much is it failing? In NLP, we can use LLM to summarize typical failure patterns or incorrect classifications. So basically you can ask LLM if it sees any patterns in the subset of your failing use cases in the textual format. So again, the evaluation is very related to the data collection and business understanding. So this is usually resolved at the very beginning of the project, and usually the high-level data scientists think about the evaluation at the very beginning of the project. And AI also helps here to make sure you're doing this in a more robust way, and also sometimes speed up, because not always you need to categorize all the things and check your evaluation yourself. You can also include some AI to do this automatically. So last but not least, let's talk about how modern AI tools techniques help with the deployment and monitoring, the last step of your CRISP-DM. MLOps, or even LLMOps, or sometimes even AIOps if you are super fancy, is critical for operationalizing models, and generative AI can streamline these complex processes. I have already mentioned that AI can generate CI/CD pipelines. For example, as mentioned in the design section, you can get AI to draft the code for your deployment pipelines, for example, for GitHub Actions, for Jenkins file. It can help with containerization. So it can help to generate the necessary configuration files for containerizing your application, to select the right base image, and so on. And the same stuff for the infrastructure as code, including monitoring. For example, Terraform modules for Datadog to calculate some statistics and configure some alerts. So this is all relatively standardized and usually decided on the stage of modeling and preparing the code. But what I want to concentrate on in this section is actually the monitoring, because this is the place where I see some shift. So of course, right now, all the providers of monitoring and dashboarding, they play with AI a lot. And what I clearly see is some kind of AI in observability, aka talk to your dashboards. For example, in the New Relic AI, you can see that you can ask, hey, what is going on with my processes, with my services? What's on fire? And it replies, hey, there is some CPU usage bump. You say hey, what changed? And it says, yeah, there is some error rate and so on. So you actually have the same data as every monitoring provider gives to you, but you are able to talk to it and try to find some bottlenecks, points of failure, and look at metrics, logs, and real diagrams together with AI. So why this is helpful? Because actually when you deploy something in the dev environment or in the QA, you are able to identify the problems sooner than when you check the logs yourself. And finally, there is one interesting direction which I haven't tried myself, but I have heard some rumors about and heard in the communities, that there is an idea that after deployment, some AI agents can continuously probe the model with new data, simulate some possible distribution shifts, and evaluate drift before it becomes critical. And it looks like real-time monitoring or active testing or red teaming when there are some swarms which try to monitor your systems continually in the real time, for example, in dev environment. and then trying to make your system fail and then return back to you with some report about how the system performs in terms of scalability, in terms of response, in terms of if the answers make sense, if it predicts something. So there are really lots of interesting ideas in how AI agents may help with the proactive system monitoring. And this is basically it with our dive to the crisp DM and how this may be automated or even optimized using modern AI techniques. To conclude, I would estimate that automation with Gen AI happens less than in classical software engineering, but it exists and it really enhances productivity if you know which tools to use and how to use them carefully, if you know that they are not ideal. Always keep in mind that there is a very high probability that there is some tool to solve your problem on each stop of the workflow we have covered. And as mentioned, I would treat modern AI tools on approximately junior level, and sometimes it is still able to be helpful, but you really have to keep in mind all the limitations we have covered. So let it be helpful to you. Thank you for watching.